Okay, so welcome everybody. This is the second lab sheet on VMware virtual machines. Today we're going to talk a little bit more in depth about the second half of the lab sheet that deals with the various networking modes supported in VMware Player. And more specifically, I will explain a little bit more in depth the networking settings that we will use for the third virtual machine, which will be our custom virtual machine. Okay, so hopefully by the end of the first session, you will have finished with installing VMware and possibly creating vPrometheus 0, which is the first virtual machine, and then cloning that to create vPrometheus 1, 2, and 3 as well. So they should exist on your hard drive and they should be ready to be configured for network. So the networking that we're going to configure in the machines will be, so virtual machine 0, vPrometheus 0, will have the default NATed, which is network address translation. So this means that there is a DHCP server running on the VMware host, and when a virtual machine starts up, it gets allocated a private IP address, and it's hidden NATed behind the your actual host. So you can access the internet and everything from it. Everything is automated. So you get assigned an IP address automatically and it just works. And that host cannot be accessed by the outside world. All right. The second virtual machine you're supposed to build is vPrometheus 1 that is in bridged mode. So this means that bridged mode is the same network as the host that's hosting the virtual machine. So this is on subnet 28 for us in the labs. There was a special little problem that we had in the labs because Prometheus, which is the virtual machine that you're working on, is already bridged to your actual computer in the lab. So now we're creating a second bridge behind that for virtual machine 1. I had a problem last week where I wasn't exactly sure of which IP address I was supposed to use for that second bridge. However, after consulting the lab oracle, Cedric, he's given me a list of IP addresses that are available. Basically, he ran an nmap with network discovery of what hosts were up in the lab, and we got a set of IP addresses that are currently not used, and we can use for our second bridges. So when you do reach that part in the lab sheet, just raise your hand, just call me to your desk, and I will tell you which IP address to use. Generally, there is a rule, sort of whatever IP address your computer has minus 50, but that doesn't always apply because it doesn't interfere with a couple of our servers in the lab. So please just call me to your desk and I'll tell you which exactly IP address to use for your bridged virtual machine 1. We'll then create a host-only virtual machine by it is a matrix reference, thank you. Virtual machine 2, vPrometheus 2 will be host only. So this is the third type of networking that is offered by VMware. This again has a DHCP server that creates a network that is private to the virtual machines that are hiding behind the virtualization host. And you can allocate a network card and use it in that network. Essentially, this is mostly used so that we create farms of virtual machines that are on the same network but not accessible from the outside world. And to do that, you just create a gateway that has access to this private network and access to the outside world, and all the traffic goes out through that one. The last virtual machine that we'll create will be a custom configuration. So essentially, we will take VMware's ability to create VMnet network cards and customize it to our needs. So at the moment, nothing is running on VMnet 8, Bridged is running on VMnet 0, and host only is running on VMnet 1 by default. What we want to do is we want to have a script that creates VMnet 0 to 8, and it allows us to do basically whatever we want, to use whichever one we want in a custom way, and then we set them up in whatever, with whatever networking information we need to set it up. Okay, so settings for virtual machine 1 and 2 are pretty straightforward, same as 0. So there is a little bit of customization that we will need to do to get virtual machine 3 running in custom mode. the first thing that we need to do is we need to download a script called VM_subnet2. If you go on Moodle, it's in there. So if I go back in this, of course, because I had to restart. Thank you, computer, very wide. Right, so we have the scripts that we need here. So VM_subnet2 is here. You'll also need fix vmnet dev. We'll talk about this later. And there are some routing utils in a folder that you will need later on as well. So what our VM_subnet2 script does is, let me see. So I'm sharing the screen. So can you please tell me if you can see this?
Nope.
Share it. Let's on. Give me a second. So we have. Okay. So stop sharing this, and I think I'll share my entire screen. It will be easier. Okay. So you can see the script. Somebody answer, please.
Yes.
Okay. Good. Thank you. Okay, so this script, what it does is there's lots of comments on it and everything, so you can see pretty much what every paragraph really does on here. What we really care about is almost all the way down. We care about this particular area here. All right, VMnet2. All right, and oh, come on. Right. Are you still here?
Yeah.
Yeah.
Unbelievable. Okay, so I think sharing the entire screen causes it to crash. So let's see. So you should be able to see the notepad now. So you should be able to see the script. All right, so VMnet2 will be configured and will run on Prometheus itself. Okay, so you will need to run this script when you start the computers, and this script will start up a network card that is called VMnet2, and we will configure virtual machine 3 to connect to the internet through VMnet2. Now this script will have an IP address, subnet mask, network, and broadcast address. Okay, so in order to know which exactly we need to use, what information we need to use for this, we will need to consult another file, the file that's called a2.net subnets. So if I go back to my browser, then we have the a2.net subnets file. Okay, so hopefully you can all see the subnets file now. So what this is we've taken the class. So we've taken the entire class C network of 148.197.30 in this case .0 that goes all the way down to 30.255, and we've split it into 64 slices. We've done this because in the lab we have 48 computers, and we need to make sure that we allocate the correct IP addresses to all 48 computers without having any IP address conflicts. All right, so you have all of your IP addresses that exist on subnet 28. So subnet 28 is your physical network card that connects you to the outside world. And what we're configuring is we're configuring a virtual network card on Prometheus that we will use to connect to the virtual machine that we're building, to our custom virtual machine. So now we need to give it an IP address. So this VMnet2 needs to have an IP address on the host. So I will do an example. I will set up my own computer. All right, so my computer is the very last one on this list. So my IP address on the subnet 28 is 11. Your IP addresses are whatever they are according to the computer that you're working on. Okay, so it's a full list. So if you're ever wondering what IP address you have, you can either type ifconfig on your host, or you can consult this file and look it up straight away. You will definitely need to consult this file to figure out which range of IP addresses actually belongs to your computer. Okay, so on this file, we have the host name, we have the IP address on subnet 28 for all of the computers in the lab, and then we have network, broadcast, and usable IP addresses for each computer individually in the lab. So they start from Farina and they go all the way down to the end of the list to, I think the last one is Hakkinen in the lab. Yep, to Hakkinen. Okay. There are a few spare ones, of course, because we have 64 networks and we only have 48 computers, and we've done this on purpose, of course. The main reason why we have 64 slices, let's do this. So who can tell me why we've split it into 64 slices and not 48 slices exactly? Anybody? Maybe somebody that remember this from...
So we can have enough IPs for everyone.
Yes, that's one part of it, but why can't we split it to 48 slices? That would still give enough IP addresses for everyone.
Because of the what do you call it? The reason why is because each subnet needs to have 2 IPs reserved, one for broadcast, one for the identification of the subnet.
Close, yes, but why 64 specifically? Because all subnet masks are binary and we convert them to decimal. So all subnet masks must be powers of 2. Yes? So 2 to the 0 is 1, 2 to the 2 is 2, 2 squared is 4, 2 cubed is 8, then we'll go 16, then we'll go 32, and then we'll go 64. So if our choices are only 32 and 64, of course we'll use 64 networks, because it's better to have a few networks to spare rather than have not enough networks to work. All right. So out of all of these 64 networks that we have available to us here, we choose our computer. So I'm going to use my computer as an example. So my network address is 30.252. My broadcast address is 30.255. And usable IP addresses for me are 253 and 254. So going back to my file, the VM subnet, I will share that again. It will become annoying, I'm pretty sure, but what can I do? Sorry about that. So my computer has a network address of 252. Yes, can you please mute your microphones if you're not asking questions? So my network address, according to the file, is 252. My broadcast address is 255, so I'm going to leave this as it is. It's just a coincidence. All right. My subnet mask is going to be sorry, give me a second. So my subnet mask is going to be 252 again, and I will explain this why in a bit. All right, again, it's perhaps a bad example that I'm using mine. It's just a coincidence that it is 252, but it is going to be the same subnet mask for all of you. Okay, you will all on these smaller networks will have what we call a /30 subnet mask, which will be a 255, 255, 255, 252. And the usable IP address that I will have for my host will be the first usable IP address for me, which is 253. So this file correctly configured for my scenario, for me working on Shumi, would have me giving a VMnet2 with an IP address of 253, a subnet mask of 252, a network of 252, and a broadcast of 255. So if I go back to the PDF, okay, so my network address is 252, my broadcast address is 255, the VMnet IP address that I'm going to use is 253, because that is my first usable IP address in the range of addresses available to me, to my computer, and my subnet mask will be 252 as explained here. All right. So why is the subnet mask 252? So the subnet mask in decimal reads like this, lots of 255s. The subnet masks in binary are a bunch of ones and zeros. All right. So what we have here, if we had the default class C subnet mask, it would be 255.255.255.0. All right. However, because we have split the network into 64 slices, we have made the subnet mask smaller because we are using more of these bits from the subnet mask for our network ID. All right. So in fact, we're using 30 of those bits. hence the /30 on this, in order to create our network, because we needed to have 64 available computers. To get 64 available computers, you need to have 6 bits available for our subnet mask. Okay? So 2 to the first, so 2, 0, so it's 1, 2, 4, 8, 16, 32, 64. Right. So we've taken away, we've stolen 1, 2, 3, 4, 5, 6 bits and turned them into ones. If it was a default class C subnet mask, it would be 8 ones and another 8 ones and another 8 ones and then 8 zeros. And that would give us 256 addresses. Okay, 2 to the 8 is 256. Out of those 256 addresses, we have our first address, which would be 30.0, and our last address, which would be 30.255. So we would need a network address and a broadcast address. So we'll take that out. So a class C network gives us 254 hosts available to use. All right, because this is what 2 to the 8th adds up to. It adds up to 256. Now, because we've taken away 64, we've split it into 64 slices, and we need these many bits in order to create those 64 slices. All right, we have essentially taken away 6 bits from this, and we're only left with 2, what we call them host bits. All right, so in binary, how many combinations can we have in 2 bits? We have 00, 01, 10, and 11. So this gives us 4 addresses. 4 addresses, 1 for our network address, 1 for our broadcast address, and 2 for our usable IP addresses. And this is how the numbers turn out to be like this. This is why we have these particular ranges of networks and IP addresses here, because we've split our network, our class C, into 64 slices. And so its 64 slice can have 4 numbers, out of which 1 will be the network address, 1 will be the broadcast address, and 2 will be the usable IP addresses. That's why the subnet mask is turns from 0 to 252, because if you multiply all of this, it becomes 252. Okay, so if you add them up, essentially, this translates from binary to decimal into 252. And that's why the subnet mask for all of these smaller networks, this /30 subnet mask, is going to have a subnet mask of 252 for all of them. So this is why that file is like that, and this is why our VM subnet script will contain the information that it contains. Okay, so custom subnet mask, because we're using a custom smaller network, essentially we are doing some CIDR, classless interdomain routing in this. All right, so once we have our range of IP addresses and we know all of the information like the subnet mask, network address and broadcast address, we can configure our network settings for our script and consequently for our virtual machines. So what we will do is we'll run the VM subnet2 script on our host with a /VM subnet2, and the ifconfig on Prometheus will now display a VMnet2 with an IP address on subnet 30 of whatever you set it out to be. Okay, whatever IP address corresponds to the first usable IP address for your computer, for your own network. So once the VM subnet script is running, we then need to basically get vPrometheus3, your virtual machine, to use VMnet2 as the networker. Okay, we need to force it to use VMnet2 as the networker to connect to. If you remember before, I said that NATing always uses VMnet8, bridging always uses VMnet0, and host only always uses VMnet1. We want to use VMnet2, we want to use it on a custom configuration. So what we need to do is we sort of need to hack the executable file for the VMX for the virtual machine. So the configuration file for each virtual machine in VMware is called .vmx. If you go into the folder where the virtual machines live, you will see that the files are there, and you can actually open this file with a text editor, with gedit or vi or whatever you like. And you'll see that there is a section in there for networking. So it refers to the network cards that are available to use for the virtual machine. What we do is we have this script called fix vmnet dev. So it fixes the vmnet devices. And once you place it inside root VMware vPrometheus 3 folder, you can run it. When you run it, it's very important that your virtual machine is powered off, not suspended, and definitely not running. Otherwise, the script will not be able to modify the configuration file. Okay, so you run the script, and that will basically change the settings of the virtual machine. So once you run it, if you go to edit virtual machine settings for virtual machine 3, you will see that you have custom network adapters for your virtual machine 3. You will have 3 because that's what we've done. So we've made it create 3 network cards in custom mode. You only need 1, so you can delete the second and third. And you can set the remaining custom adapter to connect to dev vmnet 2. This means that physically, sort of, it will be connected onto vmnet 2 on the host that we've just configured with our VM subnet script. And essentially, once it's connected, you can boot up the virtual machine and you can set up the IP address on your ENS33 network card for your virtual machine 3 and connect. The IP address on VP3, in my scenario, for example, would be 30.254. So it would be the second available IP address in my range of addresses to use. So it will be the same for all of you as well. So if, for example, you're working on Ascari, then your IP address for vmnet2 inside the VM subnet script will be 30.9, and the IP address for your vPrometheus 3 ENS33 network card will be 30.10. We only need to use 2 IP addresses for this configuration, and that's it basically. All right.
Just a quick question.
Yeah,
Is this, because also you know me from last year, is this literally what we did last year for system admin internet working?
Yes, it's the same principle. So it's still CIDR. Okay, so it's still classless in the domain routing. So we are creating customized network ranges, and we're allocating them to computers, and then we're customizing the scripts that are running our virtual machines. But we didn't do it in VirtualBox. We did it in VMware Player again.
Sounds lovely, just like how much I
Yeah,
enjoyed
that's
my
true.
year like
So,
it.
yes, for some of you, this will be familiar. For some of you, this will be completely new, and it's fine. I'm there to explain this. I expect to explain this again in the lab a few times. And I'm
Wait, we're doing on VirtualBox?
yeah.
Okay, okay.
No, this is on VMware. Yes,
okay.
we're still
So
talking
it's the
about
same as last
VMware
year.
Lab Suite. Yes, it
Well,
is
the
same.
first year.
Okay.
Okay.
The script is slightly different in that we're not starting 4 network cards like last year. We're only starting the one, the VMnet 2 network card. This is the only difference, really.
Okay.
Okay, good.
Makes sense.
So once you have that in place, so once you have VM subnet 2 running with the correct IP address, once you run the fixed VMnet dev script once and it's given the custom network cards to VP3, and you've started VP3 and you have configured the correct IP address for ENS33 network card, you should be able to ping from vPrometheus 3 to your Prometheus host at the bare minimum to the VMnet 2 network card. You should really be able to ping any other IP address on your host as well. Okay, so that should be as far as it goes. Now, as a final task, what I want you to do is, if you have spare time, so if you think that you've finished this, or towards the end of the semester, maybe if you're finished with all of the other lab sheets and all of the essential tasks, then I want you to try to set up routing on Prometheus so that you get internet access going onto virtual machine 3. Now, in order to do this, you will need to basically go back to Moodle. And what I have here, I have a folder that's called routing utils. And in there, I do have the routing lab sheet for reference from previous years. And I have an example, zebra.conf and ospfd.conf file.
We did that as well. I remember that.
Yeah, exactly. Okay,
Yeah.
so I won't go through the process of explaining all this now. If you do reach to it and you want some more information about it, then you can just call me and I can explain it to you straight away in the lab. There's only a couple of details that you need to know, basically. Basically what goes into zebra.conf and spfd.conf, and everything else is pretty much on the lab sheet. All right. Oliver, the deadline for this coursework will be, I thought I mentioned it in the slides on my introductory lecture. It's the last week that we're teaching. So if you give me a second, I'll give you the exact date. If I can go to my calendar. Yes. Right, so looking at teaching block 2, we have April, we'll go away for Easter, we'll come back. Okay, so the deadline for the logbook is Thursday, the 12th of May. Okay, I don't know if you can all see my calendar. So this is it. So these are the 4 last sessions in which I will assess all of your logbooks. I will sit with you on your computer one by one, have a quick look at your computer, have a look at your logbooks, and then give you a mark for them. And then you submit them. It will be at the end of the day. It will be around 6 o'clock. The deadline for the logbook, and that will be it. Okay. So that's that. This is the lab sheet, and this is what you will need to configure for it. It is pretty straightforward as long as you understand what's happening with the IP addresses and everything else. Generally, the idea is you're sitting on a specific computer, you use a specific range of IP addresses for that computer. So you have a network and a broadcast that define the limits of the network. And then you have 2 usable IP addresses to use to the 2 network cards that you need to configure in order to make this work. The one network card being VMnet2 on the host that runs with VM subnet, and the other network card being your ENS33 network card on virtual machine 3. That is a custom network card that is created by running the fixed VMnet dev script. All right. So I'll stop the recording.